Good evening, everyone. Welcome to my YouTube channel. This is Teacher Moses C. Kusima, teacher of physics and mathematics at all levels, that is O level and A level. But I have majored so much in physics. So today we are going to be discussing about paper 2 in physics O level. Paper 2 physics O level has 3 branches that are examinable. That is light, then we have mechanics, and then electricity. So today we are going to be going through this item. We're going to be going through this item here. This is mechanics. So you're going to read through the item and look at the order of answering of these physics items. So the item goes, the physics laboratory of your school has just received a new supply of uniform meter rulers. Before these meter rulers can be used in the practical lessons, the laboratory attendants wants to ensure that each has a mass within the acceptable range of 65 grams to 120 grams. Unfortunately, the laboratory does not have a weighing scale. As a physics student, you have been called upon by the laboratory attendant to help him determine the mass of one of the newly supplied meter rulers. Task: carry out a scientific investigation to determine whether or not the mass of the meter ruler lies within the expected range of 65 grams to 120 grams. So you have read through the item. First and foremost, you need to first know where does this item come from, because each item in the practical paper have a principle, it has a law, it has a branch of physics where it comes from, Now, by looking at this question, and after going through this question, it is coming from the topic of principle of moments. So you need to first know the background of the task. You need to first know the background of the task. How? The background is principle of moment. So we need to first come and maybe do some simple sketch here. So if this is our meter rule, of course, we need to first come up with the center of gravity of this meter rule here. So we shall have our meter rule here. Maybe we have come up with its center of gravity here. Now maybe we suspend it here. And maybe I have my mass here. Let's call it capital M. Then here we shall be having the weight of the meter rule acting at that point. And I'm going to call this distance here to be distance D. Then I'm going to call this distance here to be distance Y, to the balancing point here. I call this distance here to be distance what? Distance X. Now, when you come and apply the principle of moment in this setting here, whereby the mass used here is 50 grams. So you shall come up with Y times small m is equal to capital M times small x, where our small x is the distance from the balancing point to the center of gravity, and then capital M is the mass of the meter rule. So we shall have this expression here. Now, as you see this one, this is if you plot y against x, it will give us a straight line. So if you plot y against xc, our slope s is going to equal to m divided by small m. So our capital M, which is the mass of the meter, is going to equal to s times small m then capital M is going to equal to 50 grams times S, because our small m is 50 grams. And in this case here, we shall be able to come up with the mass of the metal roll. But in this case here, remember, you must come up with a set of values that we have to plot. So we shall be changing the position of the mass here. Maybe we can begin with hourly equal to 2 centimeters, then we keep on changing at a given interval. Now let us go back to our task here. Now in our task here, we need to begin by coming up with the title for this experiment. So let us put down title. This is the order title. So title must have aim and a purpose. So we shall say an experiment to determine the mass of the meter roller. The mass of the meter roller in order to help the lab attendant to confirm or to find out whether its mass lies within the acceptable what? Acceptable range. Now this is that is our title. The title must have the aim. The aim is finding the mass of the metal rule. Now, why are we doing this? To help the lab attendant to find out whether its mass lies within the acceptable range before they can be used in the physics experiment. Now, what follows here, they are supposed to be variables. So we come to variables. Now, under variables, we have independent variables. Independent variables. Now, for this case here, an independent variable is like a variable that you have to be having in order to come up with the dependent variable. Now, for this case, if we go back here, our independent variable here is going to be D. We shall be changing this special distance of this standard mass of 50 grams. So we shall say our independent variable is going to be distance what? Distance D. That is going to be our independent. Then our dependent variable is going to be distance x and y. Distance x and y. Those are the dependent variables. Then we move on to control variable. For this case, we shall not have a direct variable. So we shall move on to control variable. Now, a control variable is a fixed variable. That value that can change, but in this experiment here, we are making it to be constant. And for this case, shall say standard mass of 50 grams. Standard mass of 50 grams. So those are our variables now. Then from the variables, we shall move to the hypothesis. This is the order. Hypothesis. Now, hypothesis is like an estimate of the expected value of the mass of the metal, but for this case, already they gave us the range. So we shall come and say the mass of the metal lies between 65 grams to 120 grams. You can even change a bit from what was being given in the question. You can edit a bit. Then from there, we shall move on to list of apparatus. List of apparatus. Now here you give the list and also the purpose of the what? Of the apparatus. See, now based the other side up on our sketch diagram, we shall need a meter rule. Meter rule, because that's what we are investigating. We shall need a knife edge. This is for providing the balancing point. You have to put it down. Then you shall need wooden block. This one is mainly to give support. Then you shall need piece of thread. This one is used to suspend the mass thread. Then you shall need 50-gram standard mass. So those are our key apparatus. You must give their purposes. You give the apparatus, you also give its purpose in that experiment. Then from there, we shall move on, and then we come to experimental setup. Experimental setup. This is going to be an experimental setup here. Now here you must draw a working setup. It must be a working diagram. Now for this case, we shall have figure 1. Now figure 1 here, we shall be finding the center of gravity because we don't know the center of gravity of this meter what? Of this meter rule. This is going to be our figure what? This is going to be our figure 1. So figure 1 here, we're going to be looking at it, getting the center of gravity of this meter rule. Shall be getting the center of gravity. This is our figure 1. Now this is going to be our center of gravity. Now figure 2, this is where it shall be. And this is going to be our working diagram. Figure 2, what you're going to be using in the experiment. So this is our knife edge. The knife edge is placed on the what? On the. Then we have our center of gravity here, G. And at this point here, that's where you have the mass of the metal acting, or the weight of the metal rule. Then here we shall be having our 50-gram mass. And then we have our distance T here from the edge of the metal rule. Then here we shall be having our distance Y. Then here we shall be having our distance what? Distance X. Then this is our figure 2. You name it here. Figure 2. Figure 2. This is going to be our experimental setups. Now from there, you must label. This is the wooden block. This is the knife edge. Knife edge. This is our standard mass. Then this one is going to be our meter rule. This one is the meter rule. Our specimen. This is going to be our thread. Label it very well. Then when everything is done, we shall be moving on to procedures. Procedures now. Procedures. Now procedures. Procedure 1. Procedure 1 here. The center of gravity, G, was determined using the figure 1. That is our first procedure in past tense. Then figure 2, the apparatus were then arranged as shown in figure what? As shown in figure 2. Then the mass of 50 grams was suspended at a distance d equal to 2 centimeters from the end of the meter rule. We shall come and say, remember, we are numbering them using numerical values, or you can be using letters. The meter ruler was adjusted until it balanced horizontally. It balanced horizontally. And then our procedure 5, distance. The distances X and Y were measured and recorded. We are measured and recorded. Then we move on to another procedure. Then from just as say procedure 3 to 5 were repeated for D equaling to 4, 6, 8, 10, and 12 centimeters. So after coming up with a number of values here, we shall come and tabulate the results. These are tabulated. We've tabulated and then graph of y against x was plotted. So after plotting the graph now here, we shall come and say the slope S of the graph was calculated. Then lastly, the mass of the meter roll, mass of the meter roller was obtained from the expression capital M is equal to 50 grams times S. Now we have come up with the expression for the mass of the meter, but where is it coming from? It is coming from our initial sketch now. And this sketch here, it's like side work. This analysis here should be done. This analysis here should be done before the beginning of the what? So that you can understand all the steps that I have to go through to do this experiment. So it can be done as side work, the sketch work. Then we can move on here. After coming up with that, what follows here is supposed to be table of results. See, table of results. We shall begin with our G, noting our G, that is our center of gravity, which we got in the first procedure. Then we shall have our table here. We have D, then we have Y, then we have X. So here we have our D. We put the unit centimeters. Then we have our Y also in centimeters. Then we have our X also in centimeters. They must be well written in the table. Then we shall come and have our table. We have our table here. So our D, we have 2.0, we have 4.0, we have 6.0, we have 8.0, 10.0, then we have 0.0. Those are the sets that we need to have a good graph. Then after coming up with our table of results, see, of course, this is a plan for our experiment. Remember, we are doing all this information here. We are doing all what we're doing right now. When we haven't touched the apparatus, this is a clear plan for us to do our practical. Then from there, we shall leave some space, of course, for data analysis here. So I can put here that after coming up with the results here, we have data analysis, which includes coming up with the plot, finding the slope, finding the intercept C in case they are needed. All those are done from there. Getting the mass of the material, substituting in the expression, all those are done from here. Then we are going to move on now to another part here, which is supposed to be sources of errors. Of errors. We must be having some error that we have incurred in the experiment. Now, the first one here, remember, each error you give, it must have a precaution. We can begin by having some parallax errors. Parallax errors. This is whereby someone cannot see the readings on the meter rule perfectly. It is 10.2, but for him is saying 10.0. So by taking 10.0, it creates an error in your what? In your results. Another one is going to be air resistance or maybe air disturbance. Air disturbance. So disturb for you to be able to get the what? The balancing point. So those are sort of errors. Then we shall have precautions. What have you done in this experiment here to minimize these errors? Precautions taken. Now, precautions here, the first one, repeating the experiment. Actually, this one applies in all experiments. Repeating the experiment, and obtain average value. Then another one, maybe closing up windows to minimize air what? The entry of air. Closing windows to minimize air disturbance. Minimize air disturbance. We can also ensuring the eyes are perpendicular. Perpendicular. When reading values on the meter rule. When reading values on the meter rule, that is another precaution that has been taken. Now, all these are done before. Now, lastly, is going to be our conclusion. Now, in our conclusion here, a conclusion must have three things. The first one, you must comment about the hypothesis. As you're concluding, you must comment about the purpose. Have you been able to achieve the purpose? You must comment about the errors. Now, how can you comment like in this case here? You have got your mass of the meter rule as maybe 112 grams. You say the experimental value for the mass of the meter rule is 112 grams, which lies within the set hypothesis, and maybe the divergence from its exact value may be brought about by the errors encountered in this experiment. Since the mass of the meter rule is 112 grams, which lies within the range that was mentioned in the scenario, so the lab attendant should go ahead and prepare these meter rules to be used in the physics what? In the physics practical. You must have the purpose, you must have the hypothesis, you must have the errors also mentioned as you are giving your conclusion. So basically, these are some of the steps that you can go through to determine the mass of the meter rule in a CBC practical level. These are some of the steps that someone can go through to determine the mass of the meter rule. Now, we may be having some other methods, but for today, I have been able to share with you this method for determining the mass of the meter rule based on this scenario. Thank you for listening. Keep on subscribing and liking my YouTube videos that I am going to be uploading here. May God bless you. Have a lovely evening.